Okay, this is the last section before your first exam. There will be a video in D2L that also just explains how to or what to expect when you go to the assessment center and take your exam and the options that you have there. So you might want to listen to that before you go take it. There's also a review in D2L that you can complete so that you're fully prepared for the exam. But let's go over this last section, and then you just know to be sure to go listen to that. So solving linear inequalities with just one variable. So I wrote all of our different inequalities up here. Sorry, that's my dog. Less than sign, so less than or equal to, if they have the little line underneath, that means it's also equal to that number. We also have a greater than sign, and then greater than or equal to. So that just means that number is actually included when it's also equal to that number. Okay, so when we have, I'm sorry, I don't know what my dog is barking at. When we're graphing or writing the solutions in interval notation, this is usually the way that I like for them to be written, is in interval notation. Brackets at either end means that that endpoint is included. So that's when you're going to use those less than or equal to signs, or those greater than or equal to signs. So if it's got the bracket, it's got to have the line underneath it on your inequality sign. We use the parentheses when those endpoints are not solutions. So that's just going to be the less than or the greater than signs. Then if it's an infinity symbol, if it goes on forever, then we're going to use this little lazy 8 here. And that's called our infinity symbol. And that one is always parentheses because it's not an actual number. So we put a parentheses out next to it. All right, so we're just going to talk about graphing. And since we're talking about just one variable here, we're just graphing on a number line. So we're going to graph x is less than 4. So here's my number line. Here is 0, 1, 2, 3, 4, 5, 6, whatever. So graph, we're going to say it's less than 4. So 4 is sort of our key point here, but it's less than that. It's not equal to 4. Notice it does not have that straight line underneath it, so it's not also equal to it. So that means it's a parentheses here. And if it's less than 4, then we're going in this direction. And so that is it graphed on a number line, all numbers that are less than 4. Well, in interval notation, notice if we just read this number line from left to right, the first thing we're going to see here is our arrow. Well, that's just pointing, and it's going to keep going forever because all these other numbers that are not even listed on my number line are also included as things that are less than 4. So that means he's going through or to negative infinity. Well, remember our infinity symbol, we always use a parenthesis. Then you just put a comma and then up to whatever number that it's up to. So we're going to say 4. Well, 4 is not included, but remember everything up to 4 is included. So like 3.999 is included, but 4 is not. So there's a parenthesis at the end of 4. All right, so another example, we're going to graph x is greater than or equal to -2. And it doesn't matter what numbers you put on here, just as long as you have some numbers on maybe both sides of whatever that critical value is. And in this case, it's -2. So I'm going to just say -3, -4. That would be -1, 0, +1, right? So our critical value that we're talking about here is at -2. Well, x is all numbers greater than or equal to, so it's also equal to that, so that means we're using a bracket. And it's greater than, so that means we're going in the positive direction, greater than. And just notice, I don't know if you sort of noticed that, but if I solve for, or when we get to solving, if I'm doing this and this x value is on that left-hand side, just notice that that arrow always points in the same direction as the inequality sign. So that also helps too. So, but that only works if the x is on the left-hand side. So if you want to solve them that way, that just makes those easier to read and are easier to put on a number line also. So my interval notation for this one that we were working on starts at -2. Remember, we're reading that just like we would read a book from left to right. So it's at -2. But -2 is included, so that means it's a bracket because of that equal sign right here. Equal. And then we're going to what? Well, that arrow is just going to keep going because that's all numbers that are greater than -2. So that's going in that positive infinity sign. And that's always with a parentheses. Now I like this last example because the graph tells me that x is between these two numbers, just like it's written here. So x is between 1 and -4. So we're just going to graph these two, make sure we have these two values on here. So -5, -4, -3. Let's just say here's 0, here's 1, here's 2. No, it's not perfect, but that's okay. 3. All right, so we're first starting at -4. Well, -4 is included because it's got that equal sign underneath there. It's less than or equal to, or x is actually greater than. So we're going to make sure we put a bracket. Then x is less than 1, but it's not equal to 1, so we're going to put the parentheses. And it's everything in between, just like it is here. X is between those two numbers, so there's my values for x. Then those are super easy to write too, because x is going from bracket -4 up to 1 parentheses. And we're done. All right, so now those were easy because we didn't have to do anything beforehand. That was just practicing our graphing, but now we're actually going to have to solve them first. Well, there is one rule that you need to remember whenever we are solving for linear inequalities. And that is when you multiply or divide by a negative number. If I'm going to multiply or divide both sides by a negative number, then we've got to switch that inequality symbol. So if it is, something like -x is less than 4, and I've got to divide through by a -1, now that's x is greater than -4. So you notice how we have to flip that sign, and that is always going to be true. So that's just something you're going to need to remember for the rest of your life, and it'll always be on a test. I guarantee you that it will be on a test to make sure that you remember to flip that sign. So whatever you have to do here in your notes to make sure you remember that, highlight it, put some big pink whatever up there. Make sure you know to flip those signs whenever you see inequalities. That should be the first thing that pops into your head, is to remember to do that. So whenever you're working with them. All right, so we have x plus 6 is less than 9. So in this case, we're going to subtract 6 because just like we've been doing, we're trying to get the value by itself. Now notice we're subtracting 6. We're not multiplying or dividing by a negative number here. We're just doing subtraction, so we're not flipping any signs yet. All right, so that means x is less than 3. Okay, so let's go draw it on a number line. Here's my critical value 3. Here's 4, 5, 2, 1. X is less than 3, not equal to, so that's a parenthesis going this way. We're going to write that in interval notation. I'm going to put interval notation, IN, right here. That's going to -infinity, always parenthesis, up to 3, parenthesis, because that's not included. So you sort of have 3 answers here. So you've got to solve the inequality. That's your solve. Then you've got to graph it, and then you may have to write it in interval notation. So you've got to do all 3 of these things on some of these problems. Okay, so let's just keep on solving. So here we're going to subtract 7x. So that gives us x minus 2 is greater than or equal to -4. So now we're going to add 2 to both sides. So x is greater than or equal to -2. All right, there's my solution. We've solved it. So we're going to go graph it now. So here, critical value at -2. So here's -3, -4, -1, 0. Okay, which direction are we going here? X is greater than or equal to. So that would be a bracket or parentheses. It's equal to, so bracket, greater than, pointing in that direction, same direction as my inequality sign as long as my x is solved on that left-hand side. So now we're writing it in interval notation. So we've got a bracket, -2, all the way to infinity. And make sure that you write those from least to greatest, reading it like a book, left to right. If you switch those numbers and put infinity to -2, that's like wrong. We can't do that. Okay, so 1/4 x is less than 2. Well, do we remember how to get rid of those fractions? I hope so. Let's see. We're going to say 1/4 x, remember, we multiply by 4, is less than 2 times 4. Remember, get rid of those fractions by multiplying by that denominator. These will cancel, leaving us with just x. So x is less than 2 times 4, which is 8. All right, there's a solution. Here's my number line, 8, 9, 10, and I think my math lab has the number lines out there for you, and you just have to learn how to put them in or draw them on there. So x is less than 8, so that's a parenthesis, pointing in less than, going down the number line. So to write that in interval notation then, -infinity up to, but not including 8. No equal sign in the inequality, so no equal, so we're using those parentheses. All right, so now we've got -6x is less than 18. Well, how are we going to solve for this? We're going to divide by -6. And whenever you see yourself dividing by a negative number, any negative number, you should be having bells and whistles going off. So you should be thinking, ding, 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 I've got to flip that sign. He's got to flip because we divided by a negative number. So whatever it takes, make those bells and whistles go off. And divide by negative, automatically go change that sign. So 18 divided by -6 is -3. And graph it on a number line. So x is greater than, but not equal to. So we've got parentheses going this way. Write it in interval notation, reading it like a book. The least number is -3 with a parenthesis. We're going to infinity with another parenthesis. Okay, so if you want to stop the video so you can work these on your own, feel free to, and then come back and check your answers. I will just continue working them out. We've got 5y greater than or equal to 20, divide by 5, so y is greater than or equal to 4. I don't know why I did that one in orange. Equal to, so that's a bracket. Interval notation, 4 bracket to infinity. All right, this one we have to use our distributive property and make sure we simplify both sides before we start crossing the line, remember. So 2x minus 6 minus 1. simplify here. A -6 minus 1 is -7. And then we're also going to simplify this. So we have 3x minus -8. Minus a -8. So remember that would really make that a positive then, because negative times a negative there makes that +8. Okay, so we're subtracting 3x from both sides. And look here, we are having to divide by a -1, which should send off our bells and whistles again. Ding, ding, ding. So bring this over here. So x now is greater than or equal to -15. So notice, I don't know what color I could put on here to make this flip that sign. Okay. Alright, so if I'm going to graph, I'm running out of room, graph this on a number line, I'm going to work upwards. So here's -15, -16, -14. It's greater than or equal to, so bracket going this way. Interval notation would be -15 to infinity. Sorry, that got a little scrunched over there. Alright, so what's going to happen here? We're going to distribute the 4. Make sure to distribute it to both numbers. Well, if I subtract 4 from both sides, that's leaving me with 0. So 8 is greater than 15. Is that true? 8 is not greater than 15, so this one has to be a no solution because this is a false statement. That is not a true statement, so that's no solution. All right, so let's look at this one. Make sure we distribute that 3 to both terms. 3x plus 3 is greater than or equal to 2x plus 1 plus x. Okay, so I can join those terms. So I get 3x plus 3 is greater than or equal to 3x plus 1. Well, in this case, if we subtract this 3x, and you have to work these down to the end to see what kind of statement they make. So that gives me 0 x's. So I've got 3. Is 3 greater than or equal to 1? Well, yes, it is. So that is a true statement. So that would be all real numbers or infinite number of solutions. So you can, I don't know what it says in my math lab, but it can be all real numbers. It can be an R with 2 lines through it like that. It can also be an infinite number of solutions. So I don't really know what that says. Okay, so just get down to the end and see whether it becomes a false statement or a true statement, and then those are your 2 answers there. Okay, so let's try one word problem here real quick. So this is what things that you need to know as this college student, right? What do I need to make in order to get a certain grade in the course? It's something that I get asked so many times at the end of the semester. So here you're going to learn how to do it. To earn a B in a course, you must have a final average of at least 80%. On the first 3 exams, you've earned grades of 82, 74, and 78. What must you make on the final exam to earn a B in the course? Okay, I get asked this so many times. So we've got grades, and we're doing averages here. And so remember, if you're going to average out the grades that you make in a class, you usually just take all the exams that you made and then divide it by the number of exams. So we are going to say we made an 82, we made a 74, we made a 78. And then what are we going to make on that final exam? We don't know yet, right? That's what we're trying to figure out. I want to be able to divide those exam grades. Well, I have 4 exam grades, so I've got to divide by 4. And I need this number to be greater than or equal to an 80 in order to get a B in the class, right? All right, so let's add up all these other numbers. So 72 plus 74 plus 78, that gives me 234 plus whatever I'm going to make on that final exam divided by 4 needs to be greater than or equal to 80. Okay, so we simplified that top, but now we need to get rid of that denominator, that fraction. So remember, we multiply both sides by that denominator. So if I multiply both sides by that 4, these are canceling out, leaving me with just the 234 plus x. And that has to be greater than or equal to 80 times 4, which should be 320. So now we just need to subtract our 234 from both sides to find out what we need to make on our test. So I need to make an 86 or greater. So x has to be greater than or equal to an 86 in order to make a B in that class. So there is your final answer of how to do those kinds. Good luck on those, that homework.